Okay, hi everybody. Welcome to DAT 210, What's New with Amazon DynamoDB. I'm Chad Tyndall. I'm a principal NoSQL solution architect here at AWS, and I focus on DynamoDB. And today we're going to be talking about what's new with DynamoDB. I'm so happy to see people came on Thursday night. I thought it would be empty, but I saw the long line outside, and that's great. It tells us that there's a lot of passion for DynamoDB and people who want to learn more about it. So I'm really happy to see that. I'm so happy to be here this week. I mean, normally trade shows are, it's part of the job, it is what it is, you go do it. But this being the first big trade show after the shutdown, it's just so good to see everybody in person and be here. And I don't know that I'll ever enjoy a trade show as much as I'm enjoying this one. But I hope you guys are having a good time like I am. All right, let's just jump right into it. Here's what we're going to talk about today. We're going to just introduce a couple of the new features from DynamoDB. We'll look at some customer examples of people who are using those features. And if we have time at the end, we'll recap some of the other features that were delivered since the last reInvent through the course of 2021. All right. Oh, sorry, I'm a slide behind. So that's what we're going to do. Well, for people who are, there might be people who are new to DynamoDB, so we'll just give a quick little intro. The great thing about DynamoDB is that it gives you this really consistent performance at any scale, single-digit millisecond response times, whether you're doing 5 reads and writes a second or 5 million reads and writes a second, you're going to get that very consistent latency from the database. And it's one of the only databases at Amazon. I think it is the only database at Amazon that has unlimited throughput and storage. We should say nearly unlimited throughput and storage, because there is theoretical, limits, but we're nowhere close to those. People like it because it gives these nice, strong enterprise features, encryption at rest, global replication across multiple AWS regions, in a way that allows you to do multi-active writes, which means that you can write in any or all of your regions at the same time. It's the only database in the AWS portfolio today that allows you to do that. Okay, the other databases that have multi-region replication, generally you have to specify one of the regions as the primary region, and that's where all the writes happen. The other regions become read-only replicas. But with DynamoDB, you can actually write in any of the regions, and it will automatically replicate across the full mesh of your, what we call a global table. When you use global tables, then you achieve that 5 nines availability SLA, which a lot of people really love. I was talking with someone over here before the session. He was saying what he really loves about DynamoDB is that the serverless aspect of it. Okay, so DynamoDB is truly serverless. There's no infrastructure really to deploy. You don't have to deploy EC2 instances or just instances of the database and figure out what size instances you want to run and how many instances you have, and if those instances are running all the time, whether you're using them or not. Okay, with DynamoDB, you just tell us really, there's 2 ways. You can either tell us how many reads and writes you plan to do, and you pay for those, or you can put it in a pure serverless pricing model where you just pay for reads and writes as you do them. Okay, if you don't do any reads and writes, you're not paying for any capacity usage. And the nice thing about the serverless model of it is that you don't have to worry about upgrades. There's no version of DynamoDB. Okay, you're just always on the most recent version. You never have to click a button that says, upgrade me to the new version. There's no maintenance window where you might experience outages for a few seconds as things get upgraded or anything like that. When we roll out new versions of DynamoDB, we just do it in a rolling fashion behind the scenes. You don't even know it's happening. Your app keeps reading and writing from DynamoDB, and it just sort of magically happens. We've rolled out our new version, and the new features are available, and you can start using them right away. Okay, so that's great. And of course, DynamoDB is a rich ecosystem inside the AWS portfolio that we plug into for various monitoring and analytics. All right, so one of the new features that we announced this week here at reInvent is the ability to optimize your DynamoDB usage if you have use cases that have infrequently accessed data. And a lot of customers do have those types of use cases where your data is growing very fast, and you want to figure out, how do I store this data in a way that makes sense so my application can use it, but it also makes economic sense for what the business is trying to do. Now, usually we talk about a data life cycle where things go, we have very hot data, maybe even in an in-memory cache, and then we might move things into DynamoDB where things are stored in very, very fast SSDs so we can access them in this single-digit millisecond time. And then we might have a life cycle that moves things along from hot to warm to cold to frozen, glacier, all of that, right? But today we're talking about this idea of infrequently accessed data, but where that data still needs to be accessible in very, very fast response times that DynamoDB gives. So we're not talking about this idea of moving things to slower, cheaper storage. We're talking about having things priced in such a way that if you access it infrequently, you can save a lot of money. And so you might have use cases. Think about when you're scrolling through your Facebook feed, okay? Obviously, you're looking at the most recent posts in your news feed first. And you might keep scrolling, and you might keep scrolling. And if you're like me on Reddit, and you get down to page 15 or page 20 because you're having a slow day at work or something like that, it happens. It happens. You know, most people don't get that far, right? They're just looking at the most recent stuff. So stuff that's further down might be less frequently accessed. Or I might go look at my photos in Facebook, and I'll look at the more recent things. But if I want to scroll back in time and see photos from 6, 7 years ago, it can take me a little while, and that's okay. But I still want to be able to see that. I don't want that data to just get thrown away. A lot of analytics use cases are like this too, where more recent data that has come into through the stream is more important, and recency is valued, but you still might have use cases that want to look back on things. And of course, retail, near and dear to our heart at Amazon, being that we have a large retail store, maybe you've heard of it. Sometimes you want to go look at your past orders. This is a very big thing. We have to keep order history forever because people want to search their orders, see things that they used to see things that they bought in the past. One hypothetical example is like, well, we've been wearing sweatpants at home for the last 2 years while we all work from home, but now we might need some nicer pants if you're going to a conference or something like that. This is purely hypothetical. I didn't just do this 2 weeks ago. Go look at my order history to see what pants I bought in 2017 and buy some more. All right. So this is something that comes up a lot, and we see these patterns in people using this, and we'll talk about some examples later of companies who are doing this as well besides Amazon. But what you see when you use DynamoDB is that frequently you start a new use case, you don't have any data in your DynamoDB table because it's a new app. Okay, so most of your costs tend to just be in the read and write throughput of putting data into your table and serving it up to your users, and your storage cost is actually quite low at the beginning. That's true if you haven't migrated a bunch of data in from some other legacy app. But as your app gets more mature and you get a bigger user base and time goes on, and your storage will grow. Okay, this is very natural. And at some point, it's possible that your storage cost can become so high that it becomes the dominant price of what you're paying for when you use databases. And if that's the case, and some of that data has the recency bias, so you care about more recent stuff more than older stuff, then you might want to consider using this new feature in DynamoDB, which we call Standard-IA, and I'll show you some screenshots of it. So when your storage starts exceeding your throughput cost, that's when you want to consider maybe using this new feature that we launched. And we'll look at some numbers to kind of make it more concrete a little bit. But there are the ways that people kind of deal with this solution today, before we launch this new feature, is that a lot of times they would just delete the old data. Dynamo has this feature called TTL, or time to live, which allows you to essentially on a row-by-row basis tell DynamoDB when that row is expired, and DynamoDB will just delete it automatically. Okay? And so you just say, well, I'm just going to keep the last 30 days, 90 days, whatever it is. I'm going to keep it in hot storage in DynamoDB, and after that, it's just gone. Okay, but then you start losing things. Maybe your marketing wants you to run reports that go back further than 30 days or 90 days, and you just wouldn't have that data anymore. So sometimes what people do is they split their data across DynamoDB and S3, and they'll say, I'm going to keep the hot data, the more recent data, I'm going to keep that in DynamoDB. Maybe I'll set a TTL on it. And when that TTL gets processed and Dynamo deletes the row, I can have a Lambda function that's connected to my DynamoDB streams, and that Lambda function can then write that data over to S3 for me, and I'll keep the older data in S3. And that works. It's very, very cost effective to do that. But now I've sort of increased my developer complexity, because now my app has to talk to DynamoDB, it has to talk to S3, so I have to interface with two services. I have to go look maybe and see if something is in DynamoDB, and then I get a miss, and then I go talk to S3, so I've introduced maybe some extra latency by having to call into both services. So, this is a very common model. A lot of people do this, and it does work great. But if you don't want to do that, this is the new feature that we've launched, this DynamoDB, we call it Standard-Infrequent access. So now there's 2 different table classes in DynamoDB, and I'll show you some screenshots in a little bit. When you go to create a DynamoDB table, you pick whether you want DynamoDB Standard class, which is everything that existed up until this week, or you have this Standard-Infrequent access table class, which you can use, and which will decrease your storage cost by up to 60%. Okay, and we'll look at some actual numbers to back that up. I was talking with the product manager for this feature is sitting here in the front row. I was talking with him before, and I asked him how many people have turned on this feature since we announced it, since we launched it, and he said, well, we don't have a customer count, but we know that hundreds of terabytes of tables have already been converted over to use this feature, which is great. That means people see the value in it, and they're moving to it right away. Okay. Of course, the main value of it is just lower storage costs. So the storage SKU went from something like 25 cents per gigabyte per month down to 10 cents per gigabyte per month. So you can save a lot of money literally just by clicking a button. Depending on what your tables look like, you might be saving thousands or tens of thousands of dollars a month, depending on how big they are. Okay? And so that's something you're going to want to look at, and we'll talk about some rules of thumb for how to know when should I use this table or when should I use that table. Okay, when should I convert, and what's the crossover point, kind of. The nice thing about this feature is, as I said earlier, it's not, you don't want to consider it as sort of a hot versus a warm storage where you have a performance trade-off in the mix. Okay, with standard infrequent access, it is the identical performance characteristics to the standard access table. It's just a shifting of costs so that storage is cheaper, but and the trade-off is then that there's a slightly higher price when you do reads and writes into this table. Okay, so it's similar to how S3 infrequent access works. And the nice thing about this is you can start using this feature without changing any of your code today. If you think that this feature is going to save you money, you just click the button in the console. You can convert your standard tables over to standard infrequent access for those tables where it makes sense, and you're done. That's it. You don't have to change your code. You don't have to change anything. So it gives you this nice flexibility, essentially, to move things over. We think, our prediction is that a majority of use cases will continue to be using the DynamoDB standard table class, but there will be some subset of use cases, storage-heavy workloads. I mean, we have tables that are using petabytes, single tables that have petabytes of data in DynamoDB. Of course, that's the far, far tail end. Most things are not like that. But if you have a table which has 1 terabyte or more of data, you should at least think about doing this analysis. It's, I don't know, it's like probably 50-50 whether you'll save money doing that. So it's really worth looking at if you have storage-heavy workloads. All right. Let's see. Yeah. So the rule of thumb here that you want to use is you want to look at your bill in the AWS Cost Explorer, and you want to add up how much you're spending on storage, and you want to add up, well, you can see how much you're spending on storage, but then you want to add up how much you're using on reads and writes, so RCUs and WCUs. And if the cost of storage is more than half of your cost of reads and writes, okay, then it probably makes sense to switch over to this new infrequent access table class. Or if you think about those 3 things, and you look on like a bar graph or something like that, and storage is 1/3 of your cost, and reads and writes are 2/3 of your cost. Okay, that means storage is half of reads and writes. Then that's really the break-even point. So if it's more than that, then you want to switch over, and that's when you would start saving 60% on your storage costs. Okay. So again, just so we have the slides here for people who are watching it after, that is the formula that you want to use and really think about. We are also in the process of building a really nice tool. One of my colleagues, Jeff Duffy, on my team is working on this. It's going to be an open source tool that you can essentially run against your account, and it can look at your DynamoDB tables and give you recommendations for just ways you can save money. Of course, this will be a big part of that, and it can look at your billing history and just say, well, based on historical usage of this table, we think it would make sense to switch. Of course, if your application somehow changes performance characteristics all of a sudden, and next month you have a lot more read and write throughput for whatever reason, then, you know, it might actually be more expensive. So you have to be careful. You don't want to switch if you know that something might change, or you're going to have a big event that's going to lead to a lot of read and write throughput next month or something like that. You are allowed to switch back and forth between standard and Standard-IA. Not that frequently, okay, but you can do it. So if you, for whatever reason, you say, well, I do have a really big event, I'm going to have a lot of read and write throughput during the Super Bowl or something like that, maybe you switch back to standard for a month and then come back to Standard-IA. Whatever makes sense, you can sort of mix and match that over time as makes sense to you. Here's an example from AWS Cost Explorer. You know, we didn't have a lot of days of history using this to generate, so we generated some load. You see on the very first day, the purple, it's all write throughput. We're just loading data into our DynamoDB table, so all the cost was write throughput. And the second day, we were still doing some writes. We started doing some reads. And the green band there that's in the middle of the second day, that is our storage cost. Okay, so on the second day, it wasn't that big. But by the third day, the storage cost had grown. And I kind of have a zoomed in picture there of that third day from November 29th. The green bar is roughly a third of the total cost. So if we switch now to the Standard-IA with this use case, we'd probably be about breaking even. Okay, the storage cost is about half of the sum of the yellow and the red bars, the read and write cost. Okay, so this is kind of the line. If the green bar got bigger as a percentage of that day, then it would absolutely make sense to switch to standard infrequent access. So we have a few customers who helped us test this out and just sort of prove it out in their environment, Mercado Libre. And I think they had a full customer session earlier in the week. But they are a large e-commerce customer down in South America. And they're using this just the way that I said, which is they're storing order histories in it. And they want to keep their order history forever so that, you know, when people are going to speak at a conference and need a new pair of pants, they can look up the old ones. And so it's just a truly perfect use case for this standard infrequent access. How often do you really look up an old order compared to, you know, how often you're buying new things, right? It's very, very infrequent that you go search your old orders. But when you do it, you want it to be very fast, right? I don't want to go look up an old order and then have it go through some really slow batch system that takes minutes to, you know, pull things off tape or something like that. When I go look up an old order, I want that to be just as fast as if I was looking at a new product today. And so this is great because it does give you the same performance characteristics as the standard DynamoDB table, which is really what you want. Okay. There's another customer that we work with, Singular. They do analytics. They do clickstream analytics. So again, this is a use case where they want to keep a long, long, long history of time series data as people click through websites so that they can do various marketing campaigns on that data. But you know, they might have older data, which they don't do marketing campaigns on all the time, but sometimes they want to go back and look at it. So putting it in the standard infrequent access makes a lot of sense for them. Jungle Scout, again, is another analytics company. Essentially, they look at what kind of products people are searching for. So they'll keep just a long stream of product search history so they can make various recommendations to retailers and such. And again, they want to keep a long history, but they might not use the older data that much. They use it infrequently, and so it makes sense to move it to this. So these are just a few customers that we already work with. Of course, with many, many customers, as we said, hundreds of terabytes of data have already moved, I think including these that we just talked about. So you know, just to put some concrete numbers to it, we drew up some scenarios, and wanted to show you some screenshots. This is what it looks like when you go create a new DynamoDB table. Of course, you create your table, you pick your partition key and sort key and all the things that are great there. But you're now presented with this choice of which table class you want to use, DynamoDB Standard, which is what existed before this week, and then the new one, DynamoDB Standard-IA. So you can pick and choose. You can convert from one to the other at any time. That's no problem. The conversion happens very quickly. So you know, what happens is your data, like we talked about, your data volume grows. In this case, this is an example where we've grown our data volume to the point where we have about 40 gigs of data and 40 million items. And so, yeah, you can see that here in the console. But now we've reached a point in our application where our throughput is stable. So that initial onboarding of data and customers has completed, and we have a very nice, stable customer usage. Maybe it goes up and down throughout the day, but we have auto scaling to help with that. And when we put that in through the cost analysis, essentially, let's say we're just using 40 gigabytes of data, and the standard rate for data in DynamoDB was 25 cents per gigabyte, and with Standard-IA it's 10 cents, that's a 60% price discount. Of course, you can see that the reads and writes are slightly different. When you move from standard to Standard-IA, the reads and writes get slightly more expensive, and that's how you do your trade-off there. So with this use case, essentially where our reads and writes are relatively low in comparison to our storage cost. We're seeing $15 for this table per month on standard, or $10 on Standard-IA. And so that's a big discount, okay? That's like 35% off or something like that of the total cost. And you might say, so what? $5 a month, who cares? It's not even worth my time to ask someone to spend an hour to analyze this table and see if we're going to save $5. That's true. But when you start multiplying this out, and I noticed this typo before I came on, but they would not let me change this presentation. There's no mechanism to do that. These are actually in terabytes. So imagine that the column on the top left says storage in terabytes. So as our data grows, if we start having a very large use case, and we have 10 terabytes of data, now we're talking about reducing the price from $3,200 a month to $2,000 a month. Okay, so that's $1,200 a month, okay, $12,000, $13,000, $14,000 a year, something like that. That's pretty good. That's pretty good. But if we start having a really big use case, and we have 100 terabytes of data in our DynamoDB table, and something like, when you have these big use cases, you don't tend to see 5 reads and writes per second. You do see thousands of reads and writes per second. So that's what we're looking at here, is maybe 3,000 reads per second, 1,000 writes per second. We price that out. We're looking at $25,000 for standard table, $10,000 for a Standard-IA table, $15,000 a month in savings. You show your boss that you save $15,000 a month just by clicking a button that took 2 seconds. You just paid for your salary for the year maybe, or something like that. Or you can now go hire another engineer or two to build new features for your application. Just like that. You saved that much money. You didn't have to change anything. You didn't have to roll out anything, nothing. You suffered no performance characteristic difference or anything. Everything just keeps working. And we tested that. So here's, this is from our load test that we ran. And the blue line on the top and I think it's the orange line on the bottom, those are the reads and writes going through. And then the red and the green that are sort of in the middle that are spiky, this is just the latency that we're seeing for reads and writes. And what happened was when we switched from standard to Standard-IA there in the middle of the test, nothing changed. Performance is the same. There was no even temporary blip in latency or anything. You see no difference. Okay, so I just want to convince you that you really won't see. This isn't like some trick I'm playing on you where it's like, I can save you tens of thousands of dollars and there's no performance trade-off. It really is true, okay? It really, really is true. So that's the new feature. It's nice to see people using it already, and I hope you guys take a look at it, and hopefully it saves you a lot of money. All right. Okay, the other new feature that we have shipped, it actually went live last week, is around how DynamoDB integrates with the AWS Backup service. So, DynamoDB has a couple of different backup options that customers can use today. One of them is called on-demand backups. And on-demand can mean literally on-demand, like you click a button and say, take a snapshot right now. But we also use it when we're talking about other types of snapshots, like things where there's a schedule. Oh, I want to take a snapshot every hour. I want to keep those hourly snapshots for a certain amount of time. I want to take a snapshot every day and keep those for a month. I want to take a monthly and keep those for 7 years. Whatever it is, okay? We also call those on demand. So anything that's just a pure point-in-time snapshot of the database, we call that on demand. And you can do that by clicking a button in the console. You can do that by issuing an API call, or you can set up a schedule for it. Okay? And the nice thing about on-demand snapshots is that they happen basically instantaneously. They aren't run against they don't consume CPU of the storage nodes where your data is residing, so they don't have a performance impact on your table. And they're just great for these types of regulatory and compliance use cases. Or disaster recovery use cases are also big for this. Sometimes people will just want to take a snapshot and copy the data to another region or another AWS account. So that people who have access to the production environment can't access it. This has always been challenging because there was no built-in mechanism in DynamoDB to copy an on-demand snapshot to another AWS region or to another AWS account. Okay, so people would build these custom scripts. Either they would use an EMR job, like a large Hadoop job, or they would use Glue or something like that to ETL their data out of DynamoDB into S3. Once it's in an S3 bucket, they can share that S3 bucket with another AWS account or copy it to another AWS region. And then they sort of write the reverse job to load the data from that S3 bucket into a new DynamoDB table in the other account or region. Lots of people do this, but it obviously is a complexity that isn't really adding value if we can give them an easier way to do it. Okay, so if you don't want to be in the business of maintaining these custom scripts to automate your backup process, we're about to give you a better way. The other thing that people struggle with sometimes is just tracking the cost of these things or allocating cost of things to various projects so that they can back charge them internally. And it's just something that requires sort of a continuous focus on that, making sure that you have all the right tags set on everything and that those tags are being used and put into reports correctly for cost usage. So last week we announced this enhanced integration with AWS Backup. AWS Backup is a backup service that exists right now, and it works with a bunch of different services inside of AWS, not just DynamoDB, but it gives you just a fully managed policy-based backup service so that you can really centrally manage whatever your policies are across multiple AWS services. So when we look at these use cases that people are trying to solve today, things that you can do with this new functionality in AWS Backup for DynamoDB, you can set up policies for your backups. So you can say, I want to take these snapshots at a certain interval, and I want to move those snapshots. After a certain amount of time, I want to move them to cheaper, colder storage, for example, that costs less money. You can copy, you can really just click a button and say, I want to copy this snapshot to another region or another AWS account. Then once that copy has completed to the other region or account, you can restore that backup into a new table in that region or account. So no more of this writing custom EMR jobs that dump things to S3 and copy them around and reload them from S3. You don't have to do that anymore. All right. You can set these sort of centralized policies. You can audit these policies using reports. If you have an auditor who wants to come in and see what your backup policy looks like and just see what all the backups are and the history there, you can do that. If you have a requirement that your backups are stored with a different encryption key than the table is stored in, some people want that. And you can do that with this new AWS Backup for DynamoDB service. The scheduling is there. You can add tags automatically to the backups. So if you set up backups with this service, any tags that exist on the DynamoDB table today will automatically be copied to the backup object as well. But if you want to apply extra tags on top of that in an automated fashion whenever the snapshots occur, you can add extra tags to that as well. And again, you can sort of manage your life cycle of these snapshots, moving them to colder storage after a certain amount of time to save money. So let's just show you, by the way, we do these screenshots because we just want to avoid any issues with the Wi-Fi going down. I know that happened earlier in the week, and so this is just keeping things safe, and you don't have to waste time watching me click around. So this is what happens when you come into the AWS Backup service to create a new backup for DynamoDB. You say, oh, I want to back it up with AWS Backup. I'm going to create a backup now. All right, this is kind of on demand. And you can specify these settings. Okay, after a certain amount of days or months or whatever it is, I want to transition into cold storage. I want the snapshot to automatically be deleted after a certain amount of time. You can put it in a backup vault and have these different encryption keys if you want to do that. This is where you can add extra tags on top of the backup. Like I said, if there's tags that already exist on your DynamoDB table, that'll be copied to the backup object. But if you have extra tags, you can add those here, and they'll automatically be applied. This is the feature that so many people have asked for years, and I'm so happy that we have it now. The ability to copy. Yes, thank you. Yes, yes. Copying things to another account or region. It's one of these things that it's funny that that's what gets claps, right? Because it's not sexy at all. It's like, oh, I can copy my data to another region. But I mean, so many customers. This is going to help. This is going to help a lot of people. Okay, the claps are funny, but also true. It's funny because it's true. Okay, so you can just come in here, click a button, copy it to another region, copy it to another account. It'll be there as soon as the copy's done. Of course, that might take a little bit of time depending on how big the snapshot is, but it'll be there. We'll notify you when it's there, and you can restore it into the other region or account whenever that's done. And then we give you this nice functionality for built-in reports. There's some built-in reports here already for your compliance auditors. It'll make them very, very happy. Right. So the key takeaways for this session, really the most important things you want to walk out here with. It's possible that you might save a lot of money for yourself, for your company, or whoever you work for by moving to this new Standard-IA infrequent access storage class. Look for this tool. We're just waiting. The tool is written, this open source tool that I was talking about. We're just waiting for the lawyers to approve it for us to open source it. It has to go through a sort of a legal review process before we put it out on GitHub. I can't tell you when. It's already in that process. It might take a couple weeks or something like that. Of course, there'll be an announcement when that happens. But take that and run that tool. And I think that's a tool that we're going to, I'm pretty sure that's a tool we're going to keep contributing to over time. Besides just moving table classes, this tool can also look at things like, do you have GSIs that you don't even use anymore? Sometimes people create a GSI, the developers who created it, they leave the company. The access patterns change, the application code changes, they don't use the index anymore, nobody knows. They're sitting here paying for storage for the index, they're paying for read and write capacity for the index. It's not even being used. So, just detecting easy, low-hanging fruit, ways that you can save a lot of money, that tool is going to be really, really cool. Okay, so run that. The formula that you want to remember is 50% of your cost of reads and writes. If more than 50% is in storage, then you probably will save money by switching to this new table class. And if you have these backup requirements where you want to do backups and copy them from region to region, or have different encryption keys for your backups in the DynamoDB table, and you have various compliance reports that you need to run, this new integration with AWS Backup can really help you out. Okay, so those are the two big announcements that came out. I wanted to recap very quickly some of the things that we announced over the course of 2021. Of course, we are constantly delivering new features, just like every AWS service. And so here's what came out. Some of the big ones here. Let's see, cloud formation. That's the next slide. Sorry, where are we here? Yeah, so we delivered a bunch of cloud formation support for features that had shipped during the previous re:Invent. Usually what happens is we ship new features, and then sometimes the cloud formation support for those features lags a little bit. And so that was the case here. So we delivered cloud formation support for CloudWatch Contributor Insights. If you haven't seen it, CloudWatch Contributor Insights is a really cool feature that allows you to see, for example, sometimes people will come to us and they'll say, I'm getting throttled, my DynamoDB table is throttling my application for some reason. I don't know why. And there's different reasons why that could happen. It might be that your table doesn't have enough capacity assigned to it. It might be that you forgot to turn on auto scaling so it can't scale up when your application gets busier. It might be that your DynamoDB modeling could be improved, and sort of a suboptimal model in the NoSQL table can lead to throttling if you have things like hot partitions or low cardinality partition keys, those types of things. And if you're in that latter case where you're running into areas of hot partitions or even items which are very, very hot, then CloudWatch Contributor Insights will show you that. When you turn it on, it can actually show you which keys are most frequently accessed, which keys are most frequently throttled, all that. And so this is a really nice feature, and of course now you can use CloudFormation to enable it. We added support for Kinesis data streams recently, and so when DynamoDB, when you change something in your DynamoDB table, meaning you insert or you update or delete a row, we can push a change event into Kinesis data streams. So you can think about that as sort of a cousin to the already existing DynamoDB streams feature that we have. You can essentially say, when I have a change event in my table, I want to push it into DynamoDB streams, or I want to push it into Kinesis data streams. And while they are cousins, they're a little bit different from each other. They have different semantics around, for example, the ordering of changes and how sharding works and things like that. So, there's some thought needs to be given for, should I use DynamoDB streams for my use case, or should I use Kinesis data streams for my use case? If you use Kinesis data streams, it's great because there's already an ecosystem of tools which are built on top of Kinesis data streams, various things like Kinesis Data Analytics and Kinesis Data Firehose. So if you do push your change events from DynamoDB into KDS, then you sort of get all this other stuff for free without having to write your own Lambda functions to provide that glue into these other services. And of course now we support CloudFormation for turning on KDS for DynamoDB. And the other thing, we call it a fast follow. We shipped global tables in 2017, so this was a fast follow in 2021. We shipped CloudFormation support for global tables. It's very complex. I know it's funny to laugh about, but it's really complex to support the CloudFormation for global tables. So it's really nice to see the team add this. It was a very frequent ask. There's a new, if you go look in the documentation, there's a new CloudFormation object for global tables. It's separate from the DynamoDB table CloudFormation object. So if you think that you're going to use global tables in the future, even if you don't need it right now, even if you're saying, I'm just going to use DynamoDB in one region, and you're a CloudFormation user, you might consider using the global tables object in your CloudFormation configuration so that it's just very easy, because now when you want to have a second region, you just add another region to the definition of that CloudFormation global table object, and rolling up to it is very easy. Okay. I think I skipped a slide, so let me back up. There was some developer stuff that we added. There's this really great tool that we shipped a couple years ago called the NoSQL Workbench. It really helps if you're working on a DynamoDB schema and you're trying to visualize what it looks like, okay? There's really two ways to do it. You can do it in an Excel spreadsheet, which is a total nightmare, and that's how we did it before we shipped NoSQL Workbench. But now we have this great tool that allows you to create your schema, add some sample data to it, see what it's going to look like, define global secondary indexes, see when the data is all reorganized around different partition keys and sort keys, what that looks like. So it makes the visualization of it very easy. You can take that sample data and the tables that you've created, and you can push that right into your AWS account if you want to do that from NoSQL Workbench. NoSQL Workbench will generate code for you. So if you're programming in Python or Node.js or Java or these other languages, it can generate sample code for you, okay, from the tables that you've defined in it, which is nice, right? You just take that code of, oh, here's how I insert an item, or here's how I get an item out of DynamoDB. It'll just generate the boilerplate for you. You can copy it into your programming language and then just modify it and go from there. So it's a really, really nice tool, both for the developers who want to use it for that, and also as you're leading up to creating your application and you need to do your schema definitions for it. Yes. The other big feature that we shipped this year, which was something that people have been asking for a really long time, which is the ability to have an audit trail of all of your DynamoDB changes. There are certain regulated industries, financial industries, healthcare industries, et cetera, which need to have a full audit trail. And in some cases, that was preventing them from using DynamoDB for certain microservices that they had. So now we support the full audit trail for data plane logging for DynamoDB, and also for anything that goes through DynamoDB streams, we have the full audit trail for that. So if you are one of those customers who was waiting to use DynamoDB until we had this data plane logging, it's there now, and you can just turn it on and go to town. All right, so yeah, this is the final slide. If you want to get started, of course, you can go to amazon.com/DynamoDB, and it's all right there. I am going to be up here for the next 15, 20 minutes or so, and my colleague Ellie, who's a DynamoDB product manager, is going to join me, and I'm happy to take any questions that you have. Well, thanks for coming today. Thanks for coming to the last hour. I really appreciate it.